Hi guys, today we are going to talk about objects. And before that I want to show you the main difference between primitive types and objects. So, as I already told you, we have about 5 primitive types, well 6, but about symbol we will talk later. And we have 5 main primitive types like numbers, strings, boolean, and also 2 preserved words, special words like null and undefined. So it's there are primitives, and we can create objects. So what's the difference? Main difference is next. Let's create some primitive, like number equal 5. Then I can create copy. Well, even I can create string. Let's call it hello. Then create copy. And let's say n equal high. And then console log copy. As you see, copy always is the same. So if I change original string, actually I didn't. I just create some new space, put new string there, and make my n variable link to this memory. And copy stays the same. But if we will take object var ob, let's create object which has a and it's equal to 5. I can create copy, and then in original I can change a equal to 6. Then console log copy a. So as you see, my copy changed too. When I change an original object, copy changed too. So they both link to the same memory space. And if I change this memory, both these variables, they will link to the same memory. And if I change one, second will change too. So this is the main difference about primitives and objects. And now we are going to talk about objects, how to create, why do we need them. Let's go. So to create object, it's very easy. I can create object like this. This is just empty object. It don't have nothing. It doesn't do nothing. Don't do nothing. But I can describe it. I can add some fields like a equal 5, b equal hello, and something like this. I can add a lot of things to this object. Why do we need that? Why do we need this? Well, actually, we can create we can create objects from the real life. For example, like var car equal, and I can create some car. I can set it has color, and its color red. It has engine, and engine is 3.0. Yeah. Also, I can add some methods. Well, actually, our objects represent objects from the real life, and usually we describe our objects telling that it has some properties, like car has color, it has engine, and for example, if we talk about table, it has width, it has height. So there is some properties. We call it fields. So if we create object in some programming language, it has fields. And also it can has methods. Methods, it's like functions which can do something. For example, our car, it can be start or run, and it should be could be function. Well, about functions we didn't speak yet, but we will. For now, just you should know just that we can add them to our objects, and like our properties, it's some variables, and functions, it's functions. So properties, just data, like color red and something like this, and functions, it's when we do something. For example, we can change color of this string, or show some message, or do something like this. We usually do it with functions. So functions, it's our code that we are run, and our car can run, it can stop, and we describe its functionality with functions, and just like this. So simple. Also, function can have other objects can have other objects. So like car can have a radio and something like this, and room can have a table and something like this. So we can describe it, and it can be A, 5, B, 6, so something like this. Yeah. This is our objects, and this is object-oriented programming. So object-oriented programming, if you look in Wikipedia, it says that it's when you programming using objects, and these objects should have fields, which is data, our data, and it should have methods, which is our functions. So simple. And also it has three properties, like polymorphism, inheritance, and encapsulation, but we will talk about it later. For now, just think about objects as object which describe with some data and can run some code using functions. That's all for now. So we have some object. Also, we can create objects like this, new object. This is we using constructor, but about constructor we will talk after we talk about functions. For now, you just need to know that we can use some constructors to create objects, and there is a lot of constructors, like new object, new array, new date, new regexp. Yeah, all this, as you see, it works fine, and all these constructors create different objects. And now we will talk about inheritance. So all objects, they use three paradigm of programming. It's inheritance, polymorphism, and encapsulation. So inheritance, it's when you inherit something. For example, like child inherit from parent, yeah. And we can create some automobile, and we can create Mercedes, and Mercedes we can inherit from automobile. So idea is in reusing some code. You can write some code and reuse it in child. So objects can have parent-child relationship. So main purpose of inheritance is reusing code. It's like when you create some automobile, it can run, it can stop, it has some properties like color, and you want to reuse it and create your own car, but you don't want to write everything from the beginning, from the scratch. You want to reuse already using code and add some your specific details, like for example like height, weight, and something like this. So to inherit in JavaScript, we using prototype, special object prototype. So we have some object, prototype. Prototype it's object from all objects inherit this prototype. It has some methods and as you see, to string, value of, to local string and others. So if we took our object, it also has a b and also it has construct, has own property, to string, value of, so it inherits from prototype. It has all code which has prototype, object prototype. Also arrays always inherit array prototype. So this is prototype for arrays. It has much bigger list of methods, well, functions. Date also has prototype, and there is also a lot of methods, but they are using for working with dates. And I can I can inherit objects myself. For example, I can create object 2 which inherit object ob. I can do it like this. Object create ob. And my object 2 has same methods and properties which has object 1. For example, I can console log ob2a and it will give me a 5, as you see, because I inherit everything from this object. I can extend it. I can, for example, create like ob2c equals 7, and I can show you this c like 7, as you see. Also, I can inherit null. If I inherit now, I will have nothing, no objects. It would be just free object. It has nothing. It doesn't even inherit properties from prototype. It's inherit nothing. It has nothing. It's just empty object. That's all. But I can inherit object prototype, and then I will inherit all methods from my object prototype, like value of, to string, to local string, and etc. Yeah. Okay, we know now how to inherit. We will talk about it a little bit more later. For now, okay, I have object, and I can use methods and fields of this object using dot notation, like object a, and I have 5. If b, I will have hello. Also, I can do it like this. Will be the same. Result is the same, as you see. Yeah, so this is the way how we usually call our fields on our objects, like color or any other fields. Also, as I said, when I inherit something, for example, of var ob2 object create ob, my ob2 and ob, they both will have this this field a. Yeah, of course. Also, I can delete this field. For example, I can try to delete object a, and as you see, I tried to delete it, but I didn't. Value is still 5, because I can't delete values from inherited objects. But if I would try to delete from original, as you see, it would be undefined. So I can delete object, I can delete field only from objects which created it. But as you see, when I try to delete it, even if it's object 2, it's like true. So delete returns true if this object is can be deleted. It's returned true. For example, if I try to delete object, I can delete even local variables. For example, var, let's say q equal 5, delete q, it returns false, because it cannot be deleted. Also for, let's say, object prototype also will be false. Yeah. So if value can be deleted, it will return true. If not, it will return false. But it doesn't mean that it's return really deleted. For example, as here, I haven't deleted, but it's returned true just because it can be deleted. Something like this. And also I can check if object was deleted like this. A in ob. Okay, I can delete it, and as you see, after I delete it, it shows false. Before I deleted, when I deleted from object 2 and it haven't been deleted, both this console log tells true. But now when I deleted from original, from OP, and it really was deleted, now it shows false, because there is no a variable in object B, and even in object ob and in object 2. Yeah. Let's go next. Well, actually, if I not deleted it, I can check if this object has this value. And also there is a console log ob has own property. There is method which was inherited from prototype, has own property. We check does this object has own property. So if it created it. Yeah. Both object ob and ob2 has property A, but only ob created it, so has own property will return true only in the first for ob, but not for opt2. Something like this. Also, for example, I can write something like object prototype has own property to string, and it will be true because prototype create has own property to string. So, and all objects which inherit this property, which inherit prototype, has property to string, but this is property of prototype. Okay, let's go next. Let's talk about properties of prototype. It has own property and some other properties. there is property is enumerable. It works next. As you remember, we write for like this, and we console log ob l. We go through all fields in object using this for loop. We do it like this. I show you last time this statement. But object has a lot of properties, and we didn't show all of them. Why? Because all properties has enumerable property, and it can be true or false. So all properties that inherit from prototype, they property enumerable is false, and when we create new property, they property enumerable is true. So for example, I can write something like this: console log ob property is enumerable, like a, and we will see, does this property is enumerable? Yes, it's true. And when we go through all properties, it will be enumerable, and we will see it. If we try to do same with toString, it will be false because it's not enumerable. So properties can be enumerable or not enumerable. We can check it with this method, and the difference, as you see, when we go through all fields. Okay, let's go next. Also, our objects can have getters and setters. What does it mean? Let's make small example. I can create getter like this: get a, return this a, set a value this a equal a, and get b, return this b. So what happened? Well, actually we create object, and we can work with this a. We can work it like this: console log a, ob a, and as you see, we can work with it. But it's bad practice. You should not do this. Why? For example, you can use this variable, and some guy creates this object, and you need this variable. You're using it, and tomorrow this guy try to rename it, and your code will be broke. So it depends on this guy. If he would change anything, he would broke it, and this is a bad practice. So that's why object-oriented programming using encapsulation. Encapsulation said that programmer should work with his objects, and he will not show how does it work. He only give you some methods like get and set methods, and inside it he can do anything. And this is really cool, because if we use getter, we know that this person return for us some value, for example this a, and we know this name. So we have like contract. We know that developer will never change the name of this method, and he will return some value for us. That's all what we know. And this developer who creates this object, he can change anything. He can rename this variable as he wants to. He can change this method like return not just a plus b. For example, if you have some bag and you return a, but you forgot that you should return a plus b, you can write it, and your code will work fine. And many people can use your code by this getter. They can get your information through this method. And yesterday they get some wrong value, today you fix it and you get right value, and they don't know what exactly have you done. You can write this a lot of things, but you did it and no one's know. All they know that they use this method and you didn't broke anything. So the good practice is not using directly fields of our objects. We always should use some methods, and these methods, if we getting some information and setting some, well, getting some field and setting some field, these methods call getter and setter, and there is even special syntaxes for it, like this, when we get and set. And I can work it like this, but also I can do it like this, like get a, as you see, 5. Also I can ob set a equal, let's say, 10. Oops. Yes, of course, the problem is here. Value. So we usually should use these setters and these getters. So this is a bad example of using. We should not use them directly our fields. And of course, we can create getters and setters, or just setters, or just getters. So for example, here I have a getter for b and no setter, so it's optional. Okay, it's getters and setters, it's simple, you can use them. Let's go further. Let's inherit this object. Let's make it like this: var ob2 object create ob. We inherited, and we put, let's ob2 a equal 10, and then we just get a. Ob2. Yeah, as you see, we created object. It has value a is 5. Then we inherited, and in inherited object we change a to 10. And when we using getters, first one return 5 from original, and second return 10, change value. So you should know and understand this, that when we inherit objects, they can have different fields, different field values, because here we just create a new one. We had one in our parent, but here we rewrite it and create new one, and our get object work with new one. Yeah, this is also a good point. You should know that. Now let's talk about our properties. Okay, we have property A and B. Very simple. every property has 4 additional properties which describe this property. For example, A has 4 properties. It's value, writable, enumerable, and configurable. B has the same. It can be writable, enumerable, configurable, and it has a value. We can get this description like this: desk equal object get own property descriptor, and here we can write objects that we want to get ob and then property. Well, let's use A. And now we have description of property A. We can see it like this: for L in desk we will console log L. So L, this is 4 properties: value, writable, enumerable, and configurable. And we can show you the values like desk L. So value is 5, writable is true, enumerable is true, configurable is true. Well, enumerable we already discussed. Enumerable is when as I show you, when we write for, we can go through all properties of this object, and all of them is enumerable. But there is also properties like toString and also properties which is not enumerable. And when we go through for, when we use loop for to go through all properties, it will show us only enumerable properties. Well, I think it's clear. Also, we can create additional properties. I can object define property ob, let's call it C, and I can describe all properties. For example, value can be 3, writable can be true, enumerable can be true, and configurable can be true. So I created new property and I can use it like other properties. For example, console log C, ob C, and it has value 3, as you see. Also, we can create getters and setters, but then we can't use value. So it well, and of course it can't use writable. So it should be like get function and set function. Yeah, like this I can create property D. It works the same as getters and setters, which was described above. Also, I can create some property using only, let's say, only one value. Let's make it like this, like property, let's say E, which has value, let's say it's 3, and all other properties will be default. So I can use it like this: E equals 3. As you see, it works perfectly. But all values will be set by default. And what does it mean? Let's find out. We can write this get on property descriptor but only for E. Like desk 2, desk 2, desk 2, and now we can see what happened. So by default, if we create a property like this, we set only value. So it has value 3, but writable would be false, enumerable would be false, and configurable would be false either. And let's try to describe D, because D was using with getter and setter. Let's see. So getter we have, setter we have, enumerable is true, and configurable is true. And by the way, I can delete just setter and use only getter, so set will be undefined. Yeah, something like this. And of course, after I create object, I can change property of this object with this defined property. For example, I can define property and like this. I can rewrite object A and set value, let's say 1. I can make it writable false, and other I will not change, like this. And after that you can see that we change, and value is 1, writable is false, and enumerable and configurable stay unchanged. Yes, so we can use define property to change some values. And we already know what does mean. Well, writable, it's when we can't change the value. Enumerable, we already know that this is when we can iterate through this field. What does mean configurable? Okay, let's make configurable false. Yeah, like this. And then we can try to change this property. We can try to configurable to true. And as you see, we have error, because we can, if property is configurable, it means that we can change its configuration. So we can configurable change back to true. Also we can let's say readable set to false. As you see, it works. Also we can change value, let's say 7. Also it works. But enumerable, well, we can change enumerable, because if property is not configurable, so we can change configurable and enumerable values. Well, this is that was make for our prototype. It has already some methods like toString, and all of them is not enumerable, and we don't want to change it, so that's why we can make it not configurable, and enumeration will be not changed, and configurations too. But still we can writable and change some values. Okay, let's go next. What about writable? I can change writable to false. Okay, I did it. And now I want to change its value. For example, ob a equal, let's say 10. and then I want to console log ob a. And as you see, I still have 5 because it's not writable. So of course I can try to put new value there, but it will not work because it's not writable. So you can't change value of this field. And the last thing that I want to say about this define property is that it returns object which is the same as object original. So console log ob equal ob2. As you see, it's true. And one more thing. So when we define property, we can define not just property but properties like this. And we can describe a lot of properties at the same time. For example, I can create property C, and it should looks like this. It should be writable. Well, it can have value 5, writable, true. Also I can have D, its value is, let's say, 10, and something like this. So that's the way I can define new properties and make and configure it. So after that I will have property C. Yeah, like this. So I have property C which value is 5. I can make it 7. We will have 7, as you see. So we can create as much as we want properties with define properties method. Let's go next. Sometimes maybe we can want to try to get our object prototype. We can do it like this. All objects has constructor, and this constructor has prototype. So this is prototype, this is the object which we was inherit. As you see, this is the main. Same we can get with ob proto. It's the same object, as you see. Of course, all objects inherit this prototype, so as you see, we inherit this object is the same. Also, we have special method object get prototype of, and here we can get prototype of some object. For example, for object we get this prototype. It's his prototype. And also we can do it like this. Object prototype is prototype of ob. So we can check if our object prototype is prototype of object ob. Yeah, well, it's it's simple, nothing special. Well, let's go next. Extensible. Let's talk about extensible. Well, we have our object ob, and I can add some new properties. For example, obc equal, let's say, 1. And this object is extensible. I can show you like this. Console log ob object is extensible. So my object is extensible, but I can try to prevent extensions like this. Object prevent extensions ob, and it's not extensible anymore. You can see it here, so it's false. What does it mean? It means if I try to add some new property like d, it will not work. So if I try to get it like this, I will get undefined, because I can't anymore create new properties. Well, it's simple. Okay, also I can do such thing. Let's see, console log desk, and I can get my configurable value. So it's true, I can configure it, but I can use object cl op, and now it's not configurable. So if I try to rerun this code, let's call it desk2, desk2. Oh, sorry, should be like this. So I sealed it. What does it mean, sealed? Sealed means that this object is not extensible anymore, and it's not configurable. So you can't configure it anymore. And also, if I, let's say, comment this, and this we don't need anymore. I just want to check if it's extensible in the end. So yes, it's not extensible. So my seal make it not extensible and not configurable. Yeah. Also, I can make it like freeze. Freeze make it not configurable and not extensible, and also not writable. So if you check it, writable value like this, you will get true the first time and false, yeah, and false second time, as you see. So freeze make object like not configurable, not writable, and not extensible. Also, you can check it with next object is sealed. We'll check if it's sealed, and there is method is frozen, which show us if it's frozen. So it's sealed and it's frozen, and now you know what does it mean. And it's almost all that I want to show you about our objects. Only one thing I want to show you at the end. It's serialization. We have some object, and I want to make it a string. I can make it like this: var s equal JSON string if I op and console log op. Well, as you see, it's worked, and I can make another conversion. I can create variable op2 which is equal JSON parse s. So string will be parsed and will become object. You can see it's like this: console log op2 a, and we will have 5. As you see, everything works perfectly. Why do we need this? We need it, well, it's used all the time because we usually send some data to the server, where some language like PHP or Java or some other language or even JavaScript in Node.js, they can save it to database and then they can back to us. So sometimes we need to parse object and make it as a string like this, send to the server, and server sends something back for us, and we want to create object from this string that server send us. And for this we use an JSON string if and JSON parse. It's called when we create from object some string and from string some objects, it's called serialization. It's very simple in JavaScript. So there is something that I want to show you also. Well, I can add some other objects here to my this object. Let's say I can have C. C can be also some object which can have a equal 5. Let's say. Also I can have some array like 1, 2, undefined, null, empty string, false. Well, that's all. Also we can have some regular expression. It creates like this. I can have some function, and I can create some error. Well, yeah, but when I run this code, I will not get everything, cause you can see, well, I can write some console log hello. Yeah, so this is a string that I've got. Oh yes, sorry, no. This is a string which I got. So there is A, there is B, there is even C with this inner object, and there is D. But as you can see, we don't have undefined. Undefined become null. So in serialization, nulls undefineds become null. Everything else is fine, but we don't see our function. Function is disappear, and type error also disappear, and our regular expression became just empty object. Yeah, so you should know it and know how serialization works, that you should never use it will never serialize functions errors, and undefined became null. Yeah, you should know that. Well, that's pretty much it about objects. We studied some specific thing about them. We know now how to create object, what is object. We know how we can create fields for these objects. We know that we can create functions, but about functions we will talk in the future. Also, we know how to inherit them, how to reuse code, and we know that all fields have four additional properties like value, writable, configurable, and enumerable. We know how to use this. properties for every field. And that's pretty much it. We also worked with serialization. We had small example. That's it for today. Thank you for watching. Have a nice day. Bye.